Beautiful question, particularly a very interesting question to deal with mod x and mod y. So, first of all, whenever mod is involved, we know if x equal to 2 satisfies it, x equal to minus 2 will satisfy it. In some form, whatever satisfying means. If x equal to 2 works, x equal to minus 2 will work. There is a mod sitting here as well. If y equal to 1.8 works, y equal to minus 1.8 will also work. So we say, I'm going to forget about negatives. I deal only with positives. I draw the x-axis, y-axis. Then I think about 2x plus 3y equal to 6. I understand this. I get this. Don't think of it as 2x plus 3y equal to 6. When x is positive, y is positive. When x is positive, x is equal to mod x. When y is positive, y equal to mod x. So I'm going to forget these three quadrants. I'm going to deal only with this quadrant. Then think about 2x plus 3y equal to 6. Then say, hey, nice. Then x equal to 3, 3 comma 0. Y is 0, that will work. 0 comma 2 will work. We join this. This is the equation. 2x plus 3y equal to 6. Nice. Then I say, hey, nice, but this is 2x plus 3y equal to 6. I'm dealing with modulus. So plus and minus both will work. So if I put x is minus 3 also it should work. If we put 0 comma minus 2 also it should work. If a point here works, a point here will work. A point here works, a point here will work. Instead of x put minus x, that will work. Instead of y put minus y, that will work. Or I'm dealing with a shape like this. It's a nice little rhombus. This being 6, this being 4. Area is half into product of diagonals. Beautiful question to drive home the idea of thinking about modulus. And so, if your mod x and mod y is involved, draw in the first quadrant. Nice and simple. Take that shape. Then say it will be mirror image here. It will be symmetric all over the board. Then we are through. You can simplify everything after that. Same funda applies for x square, y square also. Best wishes.